Welcome to Quantum Computers Explained, the future of computing in 2025. In this video, we'll demystify quantum computing, exploring its fundamental principles, current state, and what the future holds, especially as we approach 2025. Quantum computing represents a revolutionary leap beyond classical computing. It harnesses the bizarre principles of quantum mechanics to solve problems that are currently intractable for even the most powerful supercomputers. Unlike classical computers that use bits representing zeros or ones, quantum computers use qubits, which can exist in multiple states simultaneously. This fundamental difference unlocks incredible processing power. At the heart of quantum computing are superposition, where a qubit can be both 0 and 1 at the same time, and entanglement, where qubits become linked and share the same fate, no matter the distance between them. Think of qubits as the fundamental building blocks. Their ability to exist in superposition and become entangled allows quantum computers to perform parallel computations on a vast scale, dramatically accelerating certain tasks. Groundbreaking algorithms like Shor's algorithm for factoring large numbers and Grover's algorithm for searching unsorted databases demonstrate the immense power of quantum computing in specific problem domains. Despite their promise, quantum computers face significant challenges, including decoherence, where qubits lose their quantum properties too quickly, and the need for robust error correction to maintain their delicate quantum states. As we look towards 2025 and beyond, we anticipate continued advancements in qubit stability, increased qubit counts, and the development of more practical quantum algorithms, moving us closer to fault-tolerant quantum computers. The potential applications are vast, accelerating drug discovery, designing new materials, enhancing AI and machine learning capabilities, and developing unbreakable cybersecurity solutions. In summary, quantum computers are poised to revolutionize various fields. While challenges remain, the rapid progress in this area makes the future of computing incredibly exciting. Stay tuned for the quantum leap,